From the online retailer Geekbuying, I received this 3D printer Type X Smart3 manufactured by QidiTech. The printer is fully enclosed and quite compact with the dimensions 37x37x40cm. The big advantage of an enclosed build space is that this enables the X-Smart3 to process materials such as ABS, which shrink significantly while cooling down. Furthermore, all moving and hot parts are protected from unintentional access when the printer is in operation. A fan on the back of the printer can be turned on to cool down the build space if needed. After unpacking, all moving parts on the printer are fixed with cable ties or screws to secure them during transport. The removal of those locks is the most time-consuming part of bringing this printer in operation. After that, all you have to do is plug in the filament holder and connect the device to your mains voltage. The X-Smart3 is now ready to use. When you start the printer for the first time, you are guided through the installation procedure via the well-responsive touchscreen, which also points to the removal of the transport locks. Another step is to level the print bed. To do this, the height of the print bed must be first adjusted via the touchscreen until the special leveling paper fits tightly between print bed and nozzle. Once this is set, the rest of the procedure is done by the printer firmware without further interaction. The height is measured on a grid of 16 points on the print bed. Once this is done, the so-called input shaper calibration runs, which is used to compensate for resonance vibrations. The printer is set to vibrations via the motors, which can be clearly heard as a humming noise that lasts for about 5 minutes. Finally, the filament must be inserted through the sensor switch on the backside of the printer. After the hot end has heated up, the filament can be fed via the touchscreen until plastic exits the nozzle. The printer is now ready for use. But first, let's take a closer look at the electronics. Most of it is located in the base of the printer and is accessible after removing a metal plate. The power supply delivers an output voltage of 24 volts at up to 14.6 amps, which corresponds to 350 watts. The mainboard turns out to be a mini PC with a 64-bit Cortex A53 processor and USB interfaces as well as a LAN socket, which, however, is not accessible from the outside. WLAN is implemented via an USB stick. The stepper motor drivers are soldered to the circuit board, so they cannot be replaced. Two supercaps ensure that the PC can shut down correctly when the printer is switched off. The firmware of the X-Smart3 is based on the open source solution Clipper, and the manufacturer of the printer complies with the requirement of the GPL license to publish the modified source code. A link to the corresponding GitHub repository of the current firmware version is available directly on the Qidi support page. That's exactly how it should be. A firmware update can be installed relatively easily via the USB stick, but it takes some time, in my case a good 20 minutes. Something the X-Smart3 doesn't like is switching the printer off and on again immediately. There should be half a minute before switching on again, otherwise an error message will appear. Print data can be sent via USB stick or transmitted through Wi-Fi. The enclosed build space means that access to the mechanics is restricted. For quick access, there is a door at the front that is held closed with magnets and a transparent lid that can be completely removed. In order to be able to remove the rest of the plastic paneling, you first have to loosen a few screws. Then it takes a bit of courage, because a few more clipped connections on the lid have to be loosened. These connectors sometimes get damaged in the process. Normally, however, this paneling does not have to be removed. All service work can also be carried out with the panels on the frame. I just wanted to give you a better look on the construction. Z-axis belt tension is adjusted by simply moving a pulley. The two belts on the motors for the X and Y axis are tensioned by first loosening two somewhat hidden screws. The tension is then adjusted with a third screw, which can be done very sensitively with this mechanism. After that, all screws must be tightened again. The movement of the printhead along the X and Y axis is designed via a so-called Core XY mechanism. This type of mechanics allows a very compact design. Furthermore, the print bed and thus also the objects to be printed are only moved along the Z-axis, which happens very slowly. The maximum print volume is 17.5 x 18 x 17 cm. The X-Smart3 is advertised as a very fast printer. The moving parts of the X and Y axis are therefore trimmed to be as lightweight as possible. This applies to the round carbon rods on which the printhead is guided along the X-axis, and also to the printhead itself. The plastic cover on the front can be removed quite easily. Before pulling out the Teflon tube, the lock must be pushed down. Two screws have to be loosened in order to be able to remove the hot end. This allows any blockages in the extruder to be removed very easily. Of course, I'm not giving up at this point and will continue to disassemble the extruder to let you take a look at all the components. The filament is pressed towards the hot end from two sides via a gear. With the pinion on the extruder motor there is a reduction of 9.5 to 1. The extruder motor is a very lightweight model with a round design. There is a flexible steel plate on the print bed which makes it easier to detach finished prints. This plate is coated on both sides and snaps well into the specified position, held in place by magnetic force. The heated print bed is specified with a maximum temperature of 120 degrees Celsius. 100 degrees Celsius are reached after about 4 minutes. After 10 minutes, 120 degrees Celsius is shown on the display and 118 degrees Celsius is measured, which is at least very close to the maximum value. The temperature in my video studio was 22 degrees Celsius at the time of the measurement. The leveling of the build plate is checked with the first print test. 9 discs, each with a diameter of 50mm, are printed evenly distributed on the print bed. In addition to the printer, I received a spool of PLA from Geekbuying, which is advertised as having a particularly accurate diameter. I can confirm that the quality of this filament isn't bad. The discs are printed at a speed of 15mm per second. The single layer that make up the discs is printed with a thickness of 0.35mm. Details on the test procedure and high-resolution photos of the results can be found on the website of How Open Is This Gadget. The print is finished after about 60 minutes, and all discs stick well to the print bed. The next print test is the obligatory Benchy with what I call normal settings. A sticker on the device makes clear, when printing PLA, which starts to soften at temperatures above 40 degrees Celsius, the top cover must be removed and the door left open, otherwise the extruder will no longer push the filament properly to the hot end. I tried printing PLA with the lid closed and the Benchy was indeed a failed print. The housing of the printer is obviously really well insulated and sealed. A second failed print was caused by a too high value for retract. With a value of 3mm I had chosen, the filament got clogged in the extruder and so the print was ruined. The manufacturer default is 1mm for retract and that works fine. For now on, as always with my print tests, I keep my mouth shut and you have to open your eyes and ears to form your own opinion about what the printer can do. After about 100 minutes, Benchy number 1 is finished. The Benchy speed test that follows now isn't about getting good looking results, it's just to point out the weak points that every 3D printer has. What is important here is explained in detail on the website of How Open Is This Gadget. In this video, it is important to open your eyes and ears again. The second Benchy is printed at 60mm per second, and is finished after 50 minutes. Benchy number 3 is printed at 90mm per second, and takes 40 minutes. Benchy number 4 is printed at 120mm per second, and is finished after only 30 minutes. I usually don't comment the print quality in my videos, but with the X-Smart3 I can't help but say it prints really fast, really well. High resolution photos of all Benchies can be found on my website. In order to print large objects quickly, as much plastic as possible must be extruded per unit of time, which is tested here. The cylinders have a diameter of 10 cm and are printed with a layer height of 0.4 mm. The speed is increased from cylinder to cylinder. Until the limit is obviously exceeded, which is higher with the X-Smart3 than with the printers I have tested so far. Again, how Open Is This Gadget provides all the numbers and background information on the test procedure as well as high resolution photos of the results. As a final test, I used the enclosed build space to print a part for my second project Homo Faciens out of ABS. It would not be possible to print this part out of ABS with a non-enclosed printer. The perforated robot chassis occupies more or less the entire build plate. The housing of the X-Smart3 is only heated by the bed heating, which is set to the maximum temperature of 120 degrees Celsius. Let's ignore the hot end. In course of printing, a temperature equilibrium is formed with 42 degrees Celsius on top and 35 degrees Celsius in the lower area. This is sufficient to print the robot chassis with the dimensions 160 x 170 x 55mm without the part coming off the build plate, nor can cracks be observed on the edges. Only the magnetically adhesive build plate bends up a little at the corners. The cuboid with the maximum footprint also exerts the maximum force on this component. With its enclosed design, the X-Smart3 from QidiTech is definitely well suited for printing ABS. As always, high resolution photos of the parts printed in this video as well as the printer itself can be found on the website of How Open Is This Gadget. Have a click. Thanks for watching and I'll be back.